Okay, we have reached the top of the hour, so we'll go ahead and get started. Good afternoon, everyone. I want to welcome you to the webinar, Fighting PFAS Through Regulation and Remedies. My name is Alyssa Knox. I am an Environment and Development Planner here with the North Central Texas Council of Governments, or NCTCOG for short. I will be moderating today's webinar. This webinar is hosted by NCTCOG and was funded through the United States Environmental Protection Agency through the Texas Commission on Environmental Quality. Before we jump in, I want to give a little bit of background on what NCTCOG is. We are a voluntary association of by and for local governments, and we exist to address the regional planning needs across our 16 county jurisdiction. We are one of 24 regional councils within the state of Texas. As part of our Water Quality Management Plan program, we host quarterly webinars on water quality and water supply topics of interest. If you have ideas for future topics, feel free to reach out to me. My email is on the screen and I will put it in the chat. It is aknox@nctcog.org. Okay, there we go. At this time, I want to go over a few housekeeping items before we roll into our presentations. Today's webinar is scheduled to last until 2:30. We're going to hear 3 presentations, and then we are going to have limited time for questions. I will I'll share instructions on how to submit quick questions at a later time. Follow-up emails from today's webinar will be sent to everyone who has registered. If you got forwarded this invitation but did not register, please email me so that you can be included in that email with the follow-up materials, including the recording. The recording will also be on NCTCOG's YouTube channel and under NCTCOG's Water Resources website under the green webinars banner. We ask that you would also please keep your microphone on mute until the question and answer period to minimize any distractions and feedback. Okay, as I said, we have a packed agenda. I'm very excited. We have 3 presentations on PFAS today. We'll be hearing first from Dr. Michael Trapp, who will present PFAS environmental concerns and evolving regulations. Samir Mathur will share with us PFAS and wastewater from research to reality. And Dr. Ned Calonge will present PFAS exposure and reduction from the National Academies of Sciences, Engineering, and Medicine Consensus Study, guidance on PFAS exposure, testing, and clinical follow-up. And then after that, we will have time for questions. Okay. Without any further ado, I'd like to introduce our first speaker today. Dr. Michael Trapp has extensive experience in environmental monitoring, sampling, chemical analysis, water quality data reporting, and over 20 years of experience in the water field, during which he cultivated a vast working knowledge of regulation and policy. He has been responsible for the development and management of projects to meet local and regional water needs, and has supervised and trained technicians, undergraduates, and graduate students in regulatory, laboratory, and field quality control practices. Dr. Trapp's research has resulted in numerous conference presentations and peer-reviewed publications. And now, Michael, you may take it away.
Thank you. And I'm just going to start out with you got a great group of speakers today. And I'm going to start by really trying to lay the groundwork and base understanding about why we care about this and what are the reactions by our regulatory community to these PFAS concerns. I know that sometimes we hear these terms and we don't know exactly what they mean. So I'll briefly kind of go over those as a starting point. So let's go to the next slide, please. And so what we say when we say PFAS, we merely mean per and polyfluoroalkyl substances. And this is really a really broad group of thousands of chemicals, man-made chemicals such as the PFOAs and PFOSs. These perfluoroalkyl compounds have if you think back to your organic chemistry days, I was a professor, and so I remember teaching a lot of this stuff to the students. I know you guys remember those long carbon chains that had hydrogens connected to all the carbons in these lipid kind of chains. It's kind of very similar structure to that, except we have fluorines on those. And along that backbone. And so this chemical structure makes for an extremely stable thermally and chemically stable compound that's very resistant to degradation and oxidation, which makes it very useful, going back to the 40s and 50s, the mantra of better life through chemistry, right? So these are one of those miracle chemicals that makes life better. But as we learn over time, everything is a double-edged sword, right? So these chemicals have been instituted in just about everything in our day-to-day lives, from food packaging to our paints, personal care stuff, since the 1940s when they were introduced. But probably what's most famous for their use, if you go to the next slide, is in the 1960s, they were introduced for firefighting. AFFF, you'll hear that term again. It's aqueous film forming foams. This again, a miracle chemical that hit the scene in the 60s. By the 1970s, the Navy was using this everywhere. The DoD was using this for firefighting. We'll go over some of the chemical properties, what made this such an amazing firefighting tool, particularly for chemical fires. By the 80s, this had migrated fully into the commercial and civilian world, with the FAA requiring the use of these chemicals, which really broadened them out across the entire community. But over time, by the 2020s, we realized, we had a really full understanding of the danger that they presented to the environment, to human impacts, and how it transports the groundwater. And so the DoD and FAA started requiring these to be phased out, and for replacements chemicals to be instituted in their place. Next slide. I do have a Ph.D. in marine atmospheric chemistry and was professor of chemistry for years, so I can't help myself by taking a look at this with you guys really briefly to understand why we care about this. So as I said before, these perfluoroalkyl substances, again, have that, a familiar look to them, from like lipids and surfactants, where you have a long carbon chain, but instead of the hydrogens, you have fluorines attached. And then so that creates a very hydrophobic kind of backbone, and then you have a hydrophilic head, similar to, if you can hit the button one more time, I'll bring up one other picture. And how this winds up working is, when you mix it with a surfactant, the surfactants, as you know, like to break up the oils. That doesn't create as, very effective, creates a foam with your fuels, but it doesn't create a very good ability to stop it from burning. But when you add these the AFFF to this, you wind up creating a water film in between the surfactant and the PFAS, and with the hydrophilic ends in the middle, and creating that barrier that stops the access of the oxygen and the fire from continuing to burn. So I just find this fascinating. It really is quite interesting how it works and why it proliferated. But that same, if you go to the next slide, that same chemistry, it allows this PFAS, this family of chemicals, to have a very different profile in the way that it moves through the environment of other forever chemicals, most notably PCBs, which has, had, decades of interest as a forever chemical, with lots of exposure across the country and prolific nature as well, being banned 50 years ago, but we're still dealing with the outcomes of that. PCBs are the other end of the spectrum. They're very hydrophobic. They like to bind to organics and small particles, and so become reservoirs of contaminated sediments. PFAS, on the other hand, again, it has that hydrophilic end, so it has a polar end that likes to interact with water and allows itself to move through the environment much more proficiently. If we kind of look at the cycle of PFAS in the environment, begins with, obviously there is no natural PFAS out there, so it's manufacturing, and so we have industrial waste, we have the emissions with then dry and wet deposition back into the environment. All of these things wind up into our water cycle, through either domestic usages or those industrial usages, wind up in our wastewater treatment facilities, and either get discharged back into our waterways, get into groundwater and surface waters again, and biosolids, which get spread into a lot of agricultural usages. Again, another pathway back into the environment. Landfills, obviously, another pathway where you're concentrating wastes and getting into the environment. And all of this, because of the high ability for it to move with water, either in groundwater and then move in plumes or along in surface waters, wind up in our drinking water systems and driving the exposure risks for humans, which is why we're here talking, and the initial round of regulations. So next slide. All right, so one other thing I kind of wanted to talk about to set the stage for this is some of the definitions you'll hear. We're trying to phase out PFAS, chemicals, and create alternatives. Many of these alternatives wind up being very similar in their chemical structure, just wind up becoming what we call short chains, right? So there's long chain and short chain chemistries of this family. The long chains are considered to be more dangerous, have a longer half-life in your body, and more resistant to degradation. The short chains are thought to be less toxic, and good alternatives. However, there's a double-edged sword again to everything. These smaller chains are much easier to move through the environment because they're less bulky as they get carried in groundwater plumes and other things like that. So I just wanted to make sure, some of these definitions and things that you'll hear out there, what we're kind of talking about when we're talking about these. Next slide, please. Okay, so now we know what it is, where it's at, and how it's moving through the environment. So how does it actually affect humans and biology out in the environment? So when we look at exposure sources and routes, obviously occupational exposure, if you're working around high concentrations, it can be transferred from mother to child through placental transfer. Inhalation, when there's particulates and atmospheric transport. But the primary pathway that PFAS is affecting folks is really ingestion, and whether that be ingestion through water or ingestion through food. That can also include either ambient concentrations in the water that's being collected and not treated before it winds up in your water systems. Bioaccumulation seems to be the primary way that you're getting exposed. I think beef is, speaking to a Texas audience, beef seems to be one of the worst culprits of concentrating. Fish as well, and then the containers that contain PFAS in them, and being transferred into the foods. EPA identifies swallowing contaminated soils. I'm not sure who that really affects, maybe my children, but it is worth noting that the EPA does recognize swallowing contaminated soils. So moving on to the next slide. Okay, once it gets in there, what does it do to your body? Due to its the structures similar to lipids can affect cholesterol with cholesterol levels incorporate itself, and your body gets confused with these chemicals that then has all kinds of downstream effects, such as affecting your thyroid, harming your liver and kidney functions, your immune system, creating colitis, harmful for your reproduction health. It creates birth defects problems, and then cancer and tumors. And a lot of the science is still being worked on with this, and I think other speakers will get into this a lot more, so I won't spend a lot of time on it. Moving on to the next slide. I'm trying to move quick because I know we got a lot of folks. And if you guys have questions on some of this, I think it'll be covered by others. But so the regulatory, now I think this is really what we want to spend some time on. What does this mean to us as water practitioners? And I kind of want to start that this is not a US only problem, obviously. PFAS is everywhere. And internationally, this has been being recognized as an issue that as a water community and as an environmental community, we need to address. And I think starting at the high end internationally, this has been known about for decades. Going back to the early 2000s, it really got on, really started gaining some traction regulatorily. I think one thing that represents this well is the Stockholm Convention on Persistent Organic Chemicals, going back to 2004, recognizing this as a chemical of concern. In 2009, they passed a resolution where they recommended eliminating the production of PFAS under most circumstances. There's a typo there. It's not 2010, 2019, I believe is the correct date, where they passed a second resolution where they removed most of those exemptions for PFAS and also recommended the banning of using the AFFF foams as well. And so, we'll see this again mirrored in the domestic regulations, where there is this recognition and then a ramp up of the regulations in response to the growing scientific understanding. Next slide, please. So domestically, the EPA recognizes that they have several authorities to regulate PFAS under the Toxic Substance Control Act, under the Safe Drinking Water Act, under CERCLA, the Comprehensive Environmental Response and Compensation and Liability Act, and other regulatory authorities. One of the, at the beginning, the EPA's focus was really focused around a lot of voluntary actions with the industrial leaders of trying to phase out these chemicals and find responses, limit their discharges into the environment. So if you go to the next slide, these early efforts going back to 2002 are really represented well by the two significant new use rules published in 2002, which required the manufacturers to provide EPA with notification of their manufacture and import, first of 13 chemicals and later growing to 75 chemicals. PFAS chemicals at this point were beginning to get voluntarily phased out by 3M as a result. And then the EPA grew, 3M was really the largest producer. And then they started to expand this, negotiating with additional PFAS manufacturers like 3M and DuPont, creating a memorandum of understanding in 2003, which detailed their plans to stop using these substances in their products and phasing them out. 2006, the EPA invited 8 more major PFAS producers to join what they called the PFAS Stewardship Program, which pledged to reduce 95% of their facilities' emissions by 2010. EPA regulations of PFAS through the Safe Drinking Water Act really began in 2009. When the EPA released provisional health advisories for PFAS and PFOS and PFOA. Beginning in 2013, probably many of you on the drinking water side began to participate in UCMR3, which monitored several species, including PFOS and PFOA and PFNA in drinking water supplies. And this really started to give a greater understanding of the breadth and width of the program and to be able to define the next steps forward. In 2016, the EPA issued a lifetime drinking water health advisory at 70 parts per trillion for PFOA and PFOS. And so this is our first real numeric targets, but these were really not enforceable, but useful for local governments that wanted to start regulating, within our federal system, which is always a nice laboratory as the federal government gets their regulations put together. But interestingly, in 2018, the Agency for Toxic Substances and Disease Registry issued a report, the toxicological profile of perfluorates, and their recommendations were between 7 and 10 times lower than the that 70 parts per trillion health advisory. Again, at this point, all of these were non-enforceable actions and really designed to help the local and tribal leaders to develop their own standards. Next slide. So the next step, real big step forward, it was in February 2019 when the EPA released their PFAS action plan. And this is a document intended to outline the steps the EPA were planning to take to protect public health by addressing PFAS. The plan indicated that EPA was moving forward with regulatory process to create a maximum contaminant level. You'll hear MCL a lot for PFOA and PFAS, and that they were going to go after designating these chemicals under CERCLA, which would make them enforceable to cleanups and dischargers under the Superfund program. So this was really that roadmap that brings us to where we're at today. But in the interim, if you go to the next slide, as I said before, our federal laboratory of states began to work with many states beginning to adopt based off of these guidances, and as well as the European guide. I'll go back, please, one more. Yeah. European guidances, their own regulations. Really started, the first two were California and Maryland, and then additionally 14 other states, closely followed by New Hampshire, Ohio, Arizona, Virginia, and New Jersey created their own sets of standards. Pennsylvania created a really comprehensive set of standards, which included things even like contaminated soil standards that are still being worked out, and a project that, became somewhat familiar with that as a project that we had here at Atkins Realis at the airport. Shockingly, there was contaminated sediments at a project, and had to work with the regulators to figure out what their regulations actually meant. So that laboratory is very much in process, and the regulators and the regulated trying to figure out what that means and how to comply with them. Next slide. The primary regulation I think that most of us are concerned with is really the drinking water standards that have been promulgated nationally by the EPA, regulating 5 different compounds here. The two that we talked about the most, obviously, being PFOA, PFOS, with really a target of 0, but an MCL, an enforceable MCL of 4 parts per trillion, which, as many of you know, is really at the limit of quantification. And so a very aggressive and low concentration, especially when you look back at the health advisory levels that were, in effect leading up into April at 70. And so this is a huge impact, which I think we'll be talking a lot about for the rest of these talks, to our, the drinking water community, of how to comply, how to test properly, with, at the level of quantifications, and comply with these, treat them. There's 3 other compounds at 10 parts per trillion, and then recognizing that these do not only act independently, but additively, you can have a contravention of the MCL individually, or if you hit the button one more time, at this ratio, the hazard index, which is kind of a ratio of all of these chemicals combined. Next slide. So what does this time frame look like? Typically, when the EPA comes up with these new rules, they usually use a 3-year time horizon. They recognize the impacts of how widespread this is, and have a 5-year time horizon on this particular rule. Within the first 3 years, there's a lot of requirements for initial and more comprehensive monitoring, and then within 5 years, instituting the treatments, which I think another speaker will be covering much more comprehensively. Next slide. I think it's important to recognize the implications of these regulations. I think the EPA does, and the community, the regulated community, definitely does. There's a number of impacts studies out there. I've done one because I was the lead consultant for the class action lawsuit, which I'll mention in the next slide. But APAW, I'll just mention APWAs because it's published. Estimated, close to $50 billion in the next 5 years in capital improvements alone, and another $3 billion in O&M, and that's only in the 5-year time horizon. Other estimates are higher, other estimates are lower, I think somewhat dependent on people's political agendas on how they create these. But just to set the stage, this is a large problem, and a lot of money is going to be spent over the next 30 years on compliance on these. But several things are out there that can help ease this burden. As part of the bipartisan infrastructure bill, there's $9 billion for communities impacted by PFAS, and another $12 billion in general drinking water improvements. And if you go to the next slide, there, close to another $15 billion going to be distributed as part of the public water systems class action lawsuit. As I said, this is something that I've been heavily involved with over the last 5-6 years. Helping create some of the damage models and scientific backup with court systems. This is a multiple defense litigation being run out of the Charleston, South Carolina federal court. 3M has put in $12.5 billion, DuPont $1.2 billion, Tyco Fire Systems $700 million, BASF $312 billion. That's all going to be distributed. There are possible other litigants that get involved, I would imagine, over time. The first phase of this litigation has just closed. I put the time frame here because I think it's important for everyone. If you're not familiar with it, become familiar with it, because there's a lot of money getting distributed. And since it is a class action lawsuit, if you are included, if you have a detection, if you want to opt out, you have to opt out. The way these lawsuits work. That is not me. You get to talk to lawyers about that. I only help handle the technical side of things. But there is a second round coming out, particularly with UCMR5 data still getting out. So the first round is closed. The second round will be closing next year, or 2026, beginning of 2026, I think. Next slide. And there's a link to that if you want to learn more about it there. So where does this go from here? Obviously, we're started the path. We're not done with the path. I put a quote from a friend of mine from the environmental law group, Wayne Rosenbaum. If you put 5 lawyers in a room, you'll get at least 10 opinions on the impacts of the recent Supreme Court decisions on the environmental regulations. I think that sums it up pretty well. There is no clear path right now. There's a lot to still get developed and changed from this political landscape and regulatory landscape and judicial landscape that's affecting this world. Next slide. The big one is Chevron, but also the Looper Bright case that came out of 2 major landmark decisions by the Supreme Court very recently that impacts the ability of the EPA and other federal agencies to regulate. I just put a couple headlines here to highlight this. If you're not familiar with it, that's another several talks. But it does hamstring and kind of confine the ability of agencies to create regulations without congressional direct authorities. So it is something that you should become aware with. It's going to have wide impacts across our entire industry, anything from designations of waters of the U.S. to chemicals and everything else. So next slide. And then I want to recognize again here that there's a lot of other regulations that are developing and on the back burner. Biosolids, big one. This it is probably one of the next things that we're going to really see. Some of the states have already banned the land application of biosolids based off of this. Maine and Connecticut, Michigan, Wisconsin, Colorado, and New York have added limits really focused on source controls. And the EPA is looking at releasing some additional rule information that they want to enforce by 2030 on biosolids. Same thing, wastewater treatment and landfill effluents. They're looking at releasing similar guidances this year with a 2030 horizon on real regulations being inserted. Surface water guidance based off of human health risks coming out, more of a guidance similar to the drinking water standards that locals can regulate from first, and then further down the horizon for those regulations coming out. And then all kinds of new regulations across the board for industrial and consumer products, from reporting and record keeping, food containers, cookware, anything that we're going to get exposures from. So that is it for me. I know we probably went a little longer than you wanted, but ready to hand off. And I think we're handling questions at the end. If not, we can handle them now.
Yeah, we'll do questions at the end. I already see some coming in through the chat, so that is great. But we'll keep going just to make sure we have time for everybody. I'd like to introduce our next speaker. Also, thank you, Michael. That was wonderful. I want to introduce Samir Mathur. He is the Global Water Reclamation Practice Leader for CDM Smith with expertise in wastewater treatment, B&R, biosolids management, and PFAS. Samir is the Senior Vice President in CDM Smith's Dallas office. He has a bachelor's degree in mechanical engineering from India and a master's degree in civil and environmental engineering from Carnegie Mellon University in Pittsburgh, Pennsylvania. He has worked at CDM Smith for over 30 years. He is involved in several of the firm's initiatives related to growing the industry's understanding of PFAS compounds and their impacts on WWRFs. And Samir, you can take it away.
Yeah, thank you. And great talk, Michael. Thank you, because it gives me a great segue into what I want to cover today in the next 30 minutes or so. So my talk is PFAS and wastewater from research to reality. So if you go to the next slide, it just cover a quick outline of what I want to talk about today, which is Michael already started talking a lot about the regulations. So I'm going to give a little more on where the regs are with respect to wastewater specifically, what's going on in the world of wastewater around the country as applies to PFAS. And then a bulk of my presentation is going to focus on these Water Research Foundation projects. We are involved in a lot of fundamental research on understanding the impact that PFAS has on wastewater treatment plants and biosolids, and how that might impact you if you're a utility or you're an engineer working on these topics. What do you take home from some of this research? So I'm going to try and give you some guidance on what this is telling us and how it might apply to potential treatment or alternatives on how to handle it at plants. So next slide, please. All right, so Michael covered a lot of this. I am not going to go into details, and this is a very complex graph here, but I just want to talk a few things here which are going to be relevant as I talk about some of these research projects. So one is the long chain and the short chain compounds, right? The long chains are the ones that have 8 or more carbon, and something less than that is short chains. We already talked in the previous presentation about how the fate and transport and how they move in the environment is impacted by the chain length. And that is going to be talked about quite a bit in one of these WRF projects I'm going to talk about. And then there's ultra shorts. The other thing I want to talk about is it's small and it's at the bottom there, but it's the precursor transformation. So there are precursors in wastewater, in the liquid media, that do not initially show up as some of the PFAS that we are interested in, but transform as you go through a wastewater plant and then show up as PFAS. And that creates another level of complication when you look at wastewater, because you may be showing something in your influent, but you may be showing higher numbers in your effluent because of this precursor transformation. So that's something to keep in mind, and we'll talk about that in a second. So let's keep going. Next slide, please. All right, you saw this graph already, this graphic. It's the point being that PFAS is detected in every part of the one water cycle. We've got it in wastewater, drinking water. We're trying to treat it. It impacts your reuse. There's a lot of it in rainwater. So it's really hard to get rid of unless you completely destroy, and that in itself is a huge challenge. So just be aware that we're not getting rid of it anytime soon. It is literally all over. Let's go to the next slide. All right, let's jump to regs. So there are a lot of, so unlike the drinking water side, where the EPA has regulated, and you saw that table that was presented on the 4 nanogram per liter per PFAS, before, we do not have any nationwide regs for wastewater. So every state is doing its own thing in a way, right? So US EPA conducted a risk evaluation, and we were talking about getting that evaluation completed by end of this year. But some states require monitoring, like California. You can see the names of the states out there. I'm not going to read them. Some have land application limits, Michigan, New York, Connecticut, and Vermont. And then some states like Maine have basically banned the land application due to PFAS concerns of biosolids. Next slide, please. So here's that EPA PFAS roadmap that was just talked about. And there was, I would encourage everyone to go find an EPA's website, that document in bold at the bottom. That's the interim guidance on PFAS destruction and disposal. It was just published a few months ago. And it's really a really good document talking about some destruction technologies, focusing on a few. And then, of course, we've got this implementation schedule you see there, where we're going to see the risk assessment come out of the EPA, hopefully by this winter, and then some final rules, and then some kind of compliance schedule, potentially. That's what we're thinking is going to happen right now, especially how it impacts the wastewater side. Let's keep going. Next slide. All right, so here is one way a state is handling it, which is state of Michigan. Unlike Maine, where they just completely banned the use the land application of biosolids, Michigan's using a little more what we feel is a more strategy that is probably more reasonable, which is that if you, based on certain sampling events, so you can see if there's you're above a certain level, which is in this case above 125 micrograms per kilogram. Then you don't allow land application, and you start looking at source reduction, and you investigate that. But if you look at the last one, and if you're well below the number of the 50 that they have there, then land application is allowed. And so EPA, we think, could be looking at this. Of course, we don't know what they're going to eventually come out with, but that's kind of where we think it's all going to land. There'll be some focus on source reduction based and look at real numbers of what your wastewater plant is actually doing. Let's keep going. Next slide. Okay, I threw these couple of slides in there. I just want to point out just a little segue into some of the next few slides I'm going to talk about. On the water treatment side, when we're doing numerous projects as a firm on the drinking water side, where we're removing PFAS from drinking water, before it gets to the water supply and into your houses. There are proven treatment technologies for PFAS removal. I'm not going to go over all these technologies, but granular activated carbon, ion exchange, membrane, all these work, and we are consistently using them on drinking water. If you go to the next slide, the trouble is that on the wastewater side, some of these don't work very well because, for instance, we have a lot of organics in our wastewater, and the granular activated carbon would get consumed at a very fast rate, so they'd be unaffordable, basically. And then I mentioned transformation. So there's a lot of other things going on with wastewater where some of these so-called conventional PFAS treatment does not work very well. So we have to look at other alternatives. And I'm not going to get deep into some of the other technologies that are out there in terms of wastewater. Like you can see pyrolysis, you have supercritical water oxidation. There's a lot of upcoming technologies that are coming out to destroy PFAS and biosolids. A lot of them are at the base level, bench scale, maybe piloting. They're not fully scalable to large size facilities, which is why if you go to the next slide, we need to start seeing what our research can guide us. So in terms of some of these technologies that are out there, like I said, they're too expensive right now, the way things are. So if someone bans biosolids, Landap, and now you're being asked to remove the PFAS in a wastewater plant, how do you do it? So where you can see while the PFAS focus primarily has been on the water supplies, now state regulators are shifting to wastewater plants. And so, everything we do in a wastewater plant gets impacted. Like your O&M could get impacted, your decisions on where to spend the money. And Michael just mentioned there's billions of dollars about to be spent. What do you spend it on? Because you still got to meet permitting, you still got to do things in a wastewater plant. So the goal of the rest of the presentation is to look through the research we've done and see how it could help us with some of those decisions. So let's go to the next slide. Okay, so I just want to quickly wrap up. What are the successful blocks of PFAS research, right? We need strategic collaborations. This is the most important, I feel. The relevant, realistic, high-quality science. The question of how does this research apply to me? How can I use it? That's extremely relevant, which leads me to number 3, which is knowledge translation from academia to practice. And then the fourth one, please click. And just, we're looking at technical solutions and some non-technical. So, everything comes into the picture. So let's keep moving. Next slide, please. All right. With that, I'm going to jump right into some of these. So Water Research Foundation, many of you may be familiar with it. It's an organization that supports a lot of research in the water industry. They provide funding. And they have most of the projects are collaborative projects between industry, consulting engineers, academia, Water Research Foundation. They're groups of people who get together and work on research and then deliver a report at the end. And sometimes there's follow-up research that goes on. So a lot of the projects sort of build upon each other, but overall it helps the advancement of science within the water industry. So the first project I'm going to talk about, WRF 5031, which was occurrence of PFAS compounds in U.S. wastewater treatment plants. And the idea was to create a comprehensive data set of PFAS occurrence, fate, and transport in liquid, solid, and gaseous phases at wastewater treatment plant. Numerous contributors to that. And again, I won't read everything here, but the point was we took samples we asked for samples from 38 wastewater treatment plants around the country and looked at how the PFAS was partitioned. So let's go to the next slide. And by the way, that QR code, if you can quickly get to it, that will take you to the website of that WRF project. So the way these slides are going to work from here on is I'll introduce the WRF project, and I'll quickly jump to what the results are saying and what they really mean to a utility, right? So the first result was that PFAS was detected in the influent, effluent, and biosolids at all 38 wastewater treatment plants, and the point being that it's everywhere, right? So that's there. Okay, we do see that concentrations of PFAS are declining over time, but they're still at concentrations of concern. So again, this could have an impact on what you do with the effluent, potentially reuse or anything else like that. The third one is the extremely important one, which is the concentrations of PFAS in effluent were higher than those in the influent. And that's what I talked about, the precursor transformation. So it's very hard to say that, oh, I've got a process and let me attack this PFAS when there's transformation going on and the effluent might be higher. And so, at that point, it becomes really tricky to try and remove it in the liquid stream, right? Okay, next one. Yeah, transformation of precursors, sustained release from biosolids. And so again, also we're seeing transformation happen in the biosolids, and sustained PFAS release could occur once you land apply the biosolids. Okay, let's go to the next slide. This what I thought was one of the interesting graphics from that WRF study. You can see that when the influent, the first thing I want to look at is relative partitioning of the PFAS once it gets to the influent through the wastewater plant. About 69% of the mass loading was in the aqueous phase, and about 31 partitioned into the biosolids phase. And also, if you can look at some of the precursors, when you look at the 66% in the influent was as precursors, which reduced to 51%. So the precursors that were reduced potentially transformed into PFAS, right? That was measured. Okay, let's keep going. Let's jump to the next one. So this is the 5082 investigation of management strategies to prevent PFAS from entering drinking water. And the idea here was to provide utilities with practical guidance, cost-effective guidance on PFAS source evaluation, right? Where is it really coming from? They looked at many areas that they sampled, such as fire training areas. We talked a lot about firefighting foam in the previous presentation. Then we looked at metal plating, landfill leachate, textiles, airports, so on and so forth, right? And to see what was going on and how they made their way into the wastewater plant. Okay, let's go on to the next slide. Okay, I wanted to point out, again, all these WRF projects have a lot of work done in them. I would encourage you to go to the website and read up on everything they're doing. I'm just picking out some highlights from these projects. But one thing I want to point out, especially as it applies a lot to our Texas audience, as you know, in Texas, we do a lot of what we call de facto reuse, which means our wastewater discharges into a river or a lake, and then after environmental buffer, we pick it up on the other side and use it for drinking water, right? And that's been going on for a long, long time. I live in Dallas. A lot of our wastewater goes down the river, Trinity River, and then Houston eventually gets that and uses that as a drinking water source. So we have a lot of this de facto reuse going on. And so the point here we're trying to make is that if you had 50%, if you took a median concentration of PFOA that's coming from a wastewater plant, and you assumed about 50% of de facto reuse going on, you would be above the MCL, that 4 milligram nanogram per liter MCL that's out there right now. So the point being that this PFAS in your effluent, at least as was measured by these WRF studies, is high enough that you could have a serious impact on some of this, the reuse work that's going on. So just something to keep in mind. All right, let's keep going. So it has to be controlled, right? And we're suggesting do it at the source. So the other thing that I didn't show you a graphic on, but one of the very interesting things out of the study was domestic water accounted for half or more of total measured PFAS in the wastewater treatment plant influent. So we talk a lot about source control, right? And we talk about controlling it at the industrial discharge level. But because there's just so much PFAS in the environment, our clothes have it, our cooking vessels have it, everything. It just comes into the domestic water supply, wastewater supply. So pre-treatment has its limitations, is the point that we're trying to make here. Okay, next bullet, please. Yep. Okay, now Las Vegas Wash, the watershed there, they were a big contributor to this work project. And a majority of the measured PFAS that entered the watershed there came from the wastewater plant, right? So wastewater plants, even though they're not producing any PFAS, they're just passively passing through PFAS, but they do end up contributing a lot to the watershed. And I think Michael was alluding to that a little bit before. So let's keep going. Next bullet. Now, based on the sampling, landfills and electroplating are relatively common points. And so again, there are places you could do some serious control, source control, and get good benefits. And next bullet. Okay, and so that was it for that one. Now we go to 5042. Now we jump over to biosolids. Is there PFAS in my biosolids, and how do we look at that? So let's go to the next slide. So this was like, how does PFAS leach through biosolids? How does it go through biosolids, right? And what's the mechanism for that? Let's go to the next slide. Okay, so this was 5042. I guess someone just went off mute. And okay, thank you. So 5042. Oh, I'm sorry. Could you stay on the last slide for a second? Yeah. This was interesting because what we did was we took biosolids in this vessel you see on the left, the glass vessel, and mixed it with clean sand, and then left it out in the open and did this for several months and went through several cycles of rain and kept measuring how rainwater with the biosolids being in the vessel, how the PFAS was leaching through it, and measured that PFAS periodically to just figure out, how what's the fate and transport look like of PFAS that's in the biosolids. Now we can go to the next slide, please. Thanks. So first result, PFAS was present in biosolid samples from 7 facilities with concentrations generally within an order of magnitude. So we saw it everywhere. And so all biosolids had PFAS. PFAS leaching from biosolids was sustained through 6 months. And even if you thought that the original PFAS you had got through, you still had precursor transformation going on. So I think that second point is very valid. A lot of variables impact when and where you measure PFAS. And so when we design these monitoring programs, we got to be very knowledgeable about that. And this is the point, I think the previous presentation, we talked a little bit about long chain PFAS leached less from biosolids and leaching decreased with greater organic carbon contact. So we just need to have more analytical methods, but the bottom line is long chain is leaching less from biosolids. So that's compared to when we look at short chain. So we measured all that. Okay, let's go to the next slide. Got to quickly jump through these because we're running out of time. So let's look at this one. So this is kind of a follow-up to the previous one. This is ongoing. We just started it a few months ago. But the idea is to measure the transformation leaching of PFAS through land-applied solids over an 18-month period now. And what we're doing is we're going to compare the leaching in 2 areas. One is where there's a land where biosolids have been applied historically, and one that's pristine land where biosolids have never been applied. And now we're going to apply biosolids to both places and see what the differences are. So like I said, this is ongoing right now. So if you go to the next slide, research is still ongoing, but we're just getting to some initial readings on this. But I think the one thing I want to point out is PFAS concentrations at the 2 foot are 2 times those as 4 feet and consist predominantly of short chain. So back to that same thing, that short chain tends to move faster, and then they are also go down further into the soil and eventually maybe groundwater, right? So again, the fact being that they're not set steady state and it's constantly moving. All right, and more work needs to be done. So let's go to the next one. Now, this is a very interesting one. So this is 50 to 12. Now we're coming back to the liquid side of things, right? And so this is the idea that, okay, can we do something in the liquid stream to remove PFAS? So what we tried was we are trying aeration and scum recovery and seeing if somehow we can concentrate. So one of the ideas you've probably seen on other PFAS presentation is concentrate and destroy, right? So what we're trying to do here is concentrate the PFAS and then remove it, and then that then becomes a stream where you can maybe destroy it easily rather than trying to treat it at a full scale level in a 50, 100, 20, whatever MGD plant, right? So that's the point. So let's go to the next slide. Okay, so we did some bench scale experiments. We also did some testing in the field on foam. We collected foam. We made our own devices to capture aerosols, to capture foam in the lab. We sent air through beakers, and what we saw, the closer, and all we did was put in like a paper towel. And we saw the closer you are, the aerosols would have more PFAS, and more PFAS would get collected in the paper towel as opposed to as you go higher. So potentially that is a place where you could potentially collect PFAS. Go to the next slide, please. So we've measured PFAS in foam in other places, and it is orders of magnitude more concentrated than your aqueous stream, right? So that's great. It's great to know that it concentrates. But here's the problem. In a typical wastewater treatment plant, we're actually trying to get away from foam, right? Because a wastewater treatment plant, the goals are different. The goals are to remove BOD, TSS, ammonia, nitrogen, phosphorus, other things. And foam creates a lot of problems in your mainstream. So where we are thinking this might go is we would go to the next slide before I come to that. So I think I have a slide showing. Yeah, that one. So the other thing we have learned. So one, we know it concentrates in the foam. The other thing we've learned that it also concentrates in the dewatering stream. So any side stream that you have coming out of your dewatering process, and you've seen other kinds of side stream treatment. You've seen it for ammonia removal. You've seen it for phosphorus removal. Well, what if we developed a side stream process where we do foam fractionation, such as technologies that are out there right now for AFFF foam or some other ways to capture, it's called foam fractionation, get rid of PFAS that way. What if we did that in a side stream or some version of that where the stream is concentrated and then got rid of PFAS that way? So that is kind of what we are envisioning right now is maybe trying out a pilot to see if we can make that system work, because we know it concentrates in both the dewatering in the side stream and in the foam, right? So what if we combine those two in some fashion? Next slide, please. So this is the conclusion of that, which is foam is substantially enriched with PFAS, and enrichment increases with the chain length. And so, of course, like I mentioned, we do not want to do this in a mainstream where we might impact the regular operation of the wastewater plant. So we want to see the side stream treatment options. And then again, our skimming and, when we started measuring those, we certainly consistently see a concentrated stream. And see, it's looking at PFAS and dewatering stream enriched maybe up to 380 times relative to the influent. And could represent a significant component of the PFAS in a wastewater treatment plant. Okay, let's go to the next slide. So I'm going to wrap up here. And, so I think the take-home message here is that we have a lot of research, a lot of papers, a lot of pilot studies going on right now of technologies. But as we stand today, a lot of them are very expensive. They're not scalable to the size of wastewater plants we typically work with. And so something has to be looked at, right? And so using science to strategically fill knowledge gaps and guide O&M can help. And we need collaboration, obviously. So I talked about potential of pilots and things. We'll have to work with our utility partners to see if we can accomplish that. And of course, once we come up with some practical solutions based on this research, we certainly want to go out there and make sure we can implement them and work with the utilities around the country. And that's all I have. Thank you.
Thank you so much, Samir. Appreciate your time and your knowledge. That was really fascinating and a lot of research to look over. So thank you. And now I'd like to introduce our final speaker of the webinar, Dr. Ned Calonge. Ned is a professor of epidemiology and associate dean of public health practice at the Colorado School of Public Health and is the chief medical officer for the Colorado Department of Public Health and Environment. He is an associate professor of family medicine at the University of Colorado School of Medicine. Nationally, Dr. Calonge chairs HRSA's Advisory Committee on Heritable Disorders in Newborns and Children and is a member of the National Academies of Sciences, Engineering, and Medicine Standing Committee on Reproductive Health, Equity, and Society. He is a past chair of the NASEM Board on Population Health and Public Health Practice, past chair of CDC's Community Services Task Force, past chair of the U.S. Preventative Service Task Force, and past chair of the CDC's Evaluating Genomic Applications in Practice and Prevention Working Group. He has served on and chaired over several NASEM consensus studies, including studies on health equity, genetic testing in medicine, safety and quality of abortion services, evidence-based public health emergency preparedness and response, PFAS testing, exposure reduction, and clinical follow-up. Dr. Calonge received his M.D. from the University of Colorado, his M.PH. from the University of Washington, and is board certified in preventative medicine. And now, Ned, you may begin your presentation.
Thanks. Could I have the first slide, please? So what I've asked to do is talk about other aspects of exposure reduction. So next slide. We know this. One thing I want to pick out of this slide is 12,000 different compounds at least. So we're talking about regulating about 6. There are many PFAS that we don't have data on, and that we'll fill in those gaps over time. I think Michael talked about this interesting compound. These are often called forever chemicals because they don't degrade quickly. And that has to do with this very strong fluoride carbon bond. And then often when they do break down, you just make another PFAS. Next slide. We've talked about all the ways that we're exposed, so I'm going to cover a little bit more of those. One of the things we didn't cover in the previous slide is lactation and breastfeeding. So I'm going to talk a little bit about that. Next slide. We know they're used in thousands of different products. Stain-resistant clothing, personal care products. So anyone who uses waterproof mascara or eye makeup, that's waterproof because of PFAS. And sunscreen that doesn't wash off in the water is also PFAS as well. Dental floss that is comfort dental floss that slides easily between your teeth does so because it's made out of PFAS. Then as you heard, there are a lot of other things, including things we hadn't mentioned like climbing ropes, guitar strings, artificial turf, and other products. We don't know to the extent to which these other products contribute to human exposures and body burden. The relative contribution of PFAS from sources other than food and water just isn't well characterized. It may be an important source of exposure for the general population, but it probably varies greatly by the individual. Next slide. So this is just a slide picking out a lot of the different areas. I think we've now mentioned almost all of these. You see products that you can use to wax your car or protect your fabric. I do want to point to the kind of operating room issue, which isn't well characterized here, but there are grafts that are made out of Gore-Tex, which is PFAS. And it's one of the last areas to be banned in states that are banning PFAS containing products because we don't yet have an alternative. Next slide. So occupational exposures, obviously, if you're in the business of creating these, you have a risk of exposure. And we talked a little bit about electroplating and painting, but also carpet installation. I think one of the major occupational exposures is being a firefighter. Even as we're taking the products out of the foam, we still have a lot of PFAS impregnated gear. Coming from Colorado, if you had prolonged work with ski wax, that's another source, although the National Ski Association has banned PFAS in ongoing ski wax. And we talked about PFAS in food packaging, but obviously people create those or use those in their jobs. And so that's another occupational exposure. Next slide. However, coming back to what you've heard before, ingestion is the most well-studied route of exposure, and it can occur through drinking contaminated water, eating contaminated seafood. And I want to highlight that a little bit because we know that PFAS does bioaccumulate in fish. And so we see up to very high levels in fish in contaminated waterways. But then you can consume other contaminated foods, such as vegetables, for which biosludge has been used as a fertilizer, or they've been protected by PFAS-containing insecticides. I want to pull out game. So there's a lot of beef in Texas, but there's also a lot of hunting, and any game that drinks contaminated water will also have PFAS in it as well. And we know that it bioaccumulates in cow's milk. So dairy products are another source. Next slide. I just wanted, since no one showed a map, just the ubiquitousness of PFAS water contamination. If you see areas where you don't see a lot of blue dots, that has probably more to do with testing or not testing than it does to do with not having PFAS in the water. Next slide. So we do think that diet is a major pathway of exposure, but we just don't have a lot of information on PFAS in commercial foods. The FDA has released PFAS data for some foods that we think could be used to model source contributions intake in the future. But for now, we don't have enough data. So for produce, meat, dairy, and grain products, the sample sizes are small, and FDA has concluded they can't use these levels to draw definite conclusions about levels of PFAS in the general food supply. And then again, we've talked about residual PFOA in food packaging, and we know that other polyfluoroalkyl phosphoric acids in food packaging get metabolized in the body to PFOA. Next slide. We talked a little bit about cookware. I think microwave popcorn bags is a source of one that's easy to change from your diet. And as we heard, you can get accidental ingestion of dust or soil. Next slide. I'd like to tell you, I know how much PFAS exposure comes from diet. We have estimates for different compounds from 16 to 99% of PFOA. So that's like a wide range, 66 to 100% for PFOS. And we don't have estimates on those individual food products. If we look at dust exposure, estimates are that 1 to 11% of human body burden from PFOA comes from dust, and 1 to 15% for PFOS. For PFOA, the dominant routes again are thought to be oral exposure from fish and seafood drinking water and dust. And for PFOS, the dominant routes are thought to be food and water, dust, and then hand-to-mouth transfer from treated carpets. Next slide. So we did hear that PFAS can cross the placenta. PFAS from the mother's body burden can be passed on to her developing fetus. And we know that maternal transfer of PFAS occurs through breastfeeding. Next slide. So to go into breast milk a little bit more, it can contribute significantly to children's serum level of some of the PFAS, with serum levels increasing from 8 to 11% per week of exclusive breastfeeding. We have found excess PFAS levels in breast milk, especially in communities impacted by PFAS water contamination, primarily through the water sources. We do not know whether lactation exposure to PFAS can have adverse health effects in children. We just haven't studied it. And we also know that formula feeding can increase PFAS exposure through contaminated formula or a formula that's been reconstituted with contaminated drinking water. Next slide. What about other exposure sources? Well, they're just not well studied. Inhalation and transdermal exposures are less well studied. We do know that you can inhale PFAS in occupational settings where there are aerosolized PFAS in the manufacturing plant. We've detected volatile PFAS indoors, and inhalation near factory emissions and incinerators contributes to exposure in the nearby communities. But we don't have data now formally evaluating inhalation from showering, for example, in contaminated water. Next slide. So exposure reduction is really based on knowing where the exposures come from and then cutting off that route. And so you've heard about bans for consumer products that many states have undertaken. It can be direct exposure to consumer products, or then the consumer products, as you heard, entering the kind of waste pathway. Industry also creates it through waste. Talked a lot about firefighting foam and how those things can get into the environment, and then the transfer of infants. So the idea is to reduce these sources. Next slide, please. It ends up that we don't know a lot about effective behavior modifications to reduce internal levels of PFAS. We do know if you eliminate the exposure, you'll eliminate the increased exposure from PFAS. A lot of what we've been talking about is reducing exposure through water filtration on a municipal water supply standpoint. Recognize that well water is another important source of drinking water for people in the United States, and municipal water filtration is not going to affect those. So there are other water filter approaches that people with well water could put in place to decrease their contamination. If there's no water contamination, diet is believed to be the primary exposure route. Again, we don't know what to recommend to not eat or drink, although it looks like seafood in highly contaminated waterways might be an advisory. There haven't been intervention studies looking at exposure reduction and impact on serum concentration. So I want to pause there for a second. So we're going to reduce the exposures, but we don't have studies that say what is that going to do in terms of human serum concentration, which is what we're really interested in. We think this is, it should make sense that to fully show effectiveness for cutting off a route of exposure, the study has to be conducted over a long enough time to account for the long half-lives of PFAS. Next slide. We do think that occupational exposures could be much higher than community exposures, and the ways to kind of use controls to reduce exposures include replacing the chemical we've talked about in firefighting foam, engineering controls like ventilation, administrative controls like limiting the exposure for one worker around the chemical, and then personal level controls like PPE and gloves and masks. Next slide. We talked a lot about drinking water already, and we know that this is something that through their regulations, EPA is really trying to work at. Again, I just mentioned private wells, and it was in April 2024 that the rules setting limits for certain PFAS in municipal drinking water was put into place. I want to pause long enough to just say the route for that determination. EPA has rules, processes where if a contaminant or a compound is known to cause cancer in humans, then there is no allowable drinking water level. And so that's how you can regulate. That's how they got from to regulating to the least detectable level, because they classified PFAS as a carcinogen based on the relationship with kidney cancer. Next slide, please. There are other routes that people can think about minimizing their exposure. 11 states have developed or in the process of putting together advisories to limit the consumption of fish, wildlife, and other food products to decrease PFAS exposure. They're state specific and they range from just don't eat it, like fish or deer in Michigan with PFOS concentrations over 300 parts per billion, to levels like no need to limit consumption, the New York fish with more than 0.56 nanograms per gram of PFOS. There is a source you can look at from the different states, from the Environmental Council of States, and this is their website, so you can see how states are looking at PFAS standards, advisories, and guidance levels. Next slide. So this is an issue we wrestled a lot with at the National Academies during the study. There are increased exposures observed in breastfed versus formula-fed infants. But we know there are benefits of breastfeeding. There are great benefits. What we don't know is enough information to weigh those two issues. Are the benefits outweighed by the harms of exposure to PFAS? So we're left with guidance to continue breastfeeding, the best advice for most infants, given the many benefits. While PFAS exposures have been occurring for many years, the research consistently shows overall benefits of breastfeeding. I think this provides confidence in our traditional guidance, although we'd like a more in-depth understanding of the exposure route to inform protection of this vulnerable population. Next slide. So I wanted to just quickly go through the 2022 recommendations for exposure reduction 4.1. These are aimed at clinicians, so not so much at those who are responsible for municipal water supplies. But clinicians should advise patients starting with how are you exposed and which exposures are you interested in reducing. You could talk about occupations, environment, drinking water with PFAS contamination, serving in the military, and consuming fish and game from contaminated areas. In terms of occupational exposure, clinicians should consult with occupational health and safety professionals to help alter the workplace practices to reduce exposure. Next slide. Patients with elevated PFAS in their drinking water can filter their water. And again, as we roll out the municipal water supply regulations, this source will be hopefully over time and after a lot of money dealt with at the municipal water source. Until that happens, you can either use another source of water or use household filters to do the same thing. If you know you have high PFAS contamination, clinicians should advise patients about the presence in fish, wildlife, meat, and dairy products. And then finally, they should direct patients to authoritative sources, and I'll give a couple of examples, but the PSAS and the ATSDR and EPA websites have a lot of great information. Next slide. This is the breastfeeding issue that just says we should at least tell parents that PFAS goes into breast milk, that the benefits are well known, and the PFAS can also be present in formula and infant food. So basically, the best approach to the lactating mother is to have the mother of children is to have that person look at their own PFAS exposure and decrease their exposure, which can impact their milk. And then we did call on federal environmental agencies to try to fill in more information. Next slide. So I wanted to have one good news slide, and this I think is a good news slide. So despite this concept of forever chemicals, they aren't forever, and they do break down in the environment. And we have seen this reduction over the years of PFAS in serum levels through the NHANES study and CDC's project. So we're going in the right direction in terms of serum concentrations in Americans, and I take this as my one kind of good news slide. Next slide. This is just a slide that will help you find areas for exposure reduction, such as PFAS REACH, that has guidance materials for communities. The information came from a number of sources that I listed on the slides, and they have an online resource center called PFAS Exchange with fact sheets and interactive maps. Next slide. There's also a group called the Environmental Working Group. Their site provides an interactive map that serves to show you the extent of water contamination by states, the Department of Defense, and EWG's testing, so that you have a sense of what might be in your community. It also provides a guide for avoiding exposure and has several consumer guides with information on lots of chemicals present in a variety of commercial products. Next slide. This is an example of a exposure reduction recommendation. This one came from PFAS REACH, and it just talks about the different exposure routes. So stain-resistant carpets, products with PTFE or other fluoro agreements, thinking about your cookware, drinking water, fresh foods, stop eating microwave popcorn that comes in the little pouch, and then look for dental floss that's uncoated or coated in wax, and then recommendations for the community. Next slide. This is just an example of the PFAS Project Lab. This is an interactive map that you can zoom in on and look for other resources. Next slide. So just in closing, I think it's clear that today it's not possible to eliminate all sources of exposure. There are sources people could try to limit if they desire, and if they have the resources to do so. If you are resource limited, it's most important that if PFAS contamination of the water is known or suspected, they use water filtration or other sources for drinking water and recognize that filtration is coming. An individual should reference reliable sources of information, and I've just listed ATSDR, the EPA, and then your own state and local health departments often have information and advisories, as we've now turned towards looking for PFAS in drinking water, characterizing the different sources, and putting in water filtration solutions and other solutions to address drinking water. The state health departments are much more knowledgeable about these issues. And Alyssa, I'm going to end there.
Thank you so much, Ned. That was really informative. Now we do have a brief time of questions. You can submit a question one of two ways. You can place it in the chat and I will read it, or you can use the raise your hand function. I will call on you to unmute and you may verbally say your question. I did see a question come in at the end of Michael's presentation. David asked, from an environmental risk and banking perspective, are there any insights on how banks may handle lending due to PFAS concerns?
I'm not sure I have an exact answer to that question, but I think what we're going to see, as in so many things in this country, the insurance companies tend to dictate as much as policy on risks. And so I think that you may wind up getting more on that side than from the banking side. But I think companies always have to disclose their liabilities, when they go after bonds. These are things that are identified. I think these are things that are being identified now in bonds for municipalities, knowing that these are on the long-term CIP lists that they're going to have to tackle. and costs they're going to have to deal with. I have one thing that I think that I'll note, having been involved with a couple really large-scale national class action lawsuits, is the difference between the class action lawsuit for the MS4s for surface waters on PCBs, dealing with Monsanto, which really dug in and tried to fight everything, uh, and was very apprehensive about admitting anything or putting money into paying for the problem, versus these four litigants being very proactive and working on these, um, recognizing the liabilities and being proactive before even the federal regulations, the MCL, were promulgated fully, to deal with liabilities, has been quite different. And so there's been a much more proactive response from the manufacturers and the polluters side of things, only over a few years, and both forever chemicals with similar profiles and stuff. So I think the world is evolving in those respects, and I think it's worth recognizing.
Thank you. Grace submitted a question noting that there has been a serum reduction in PFAS, which is great, but is there bioaccumulation in PFAS in other human tissues?
It appears that the major body burden source is blood. Now, we don't have we don't have tissue samples from people with high serum levels to talk anymore about that. We did talk about different matrices for testing, and it ends up that far and away, folks believe that the most important source or the most important matrix is blood and serum. But we don't have studies on liver tissue and concentrations in liver or concentrations in kidney, both of which are organs that we know PFAS negatively impacts.
Thank you, Ned. I'll give folks another minute or so if you have questions. These are really great, and this is a really important topic. So take advantage of our very knowledgeable speakers and feel free to ask your question.
Easy crowd.
Right?
Yeah, right.
All right, so seeing none other questions, we will go ahead and move to wrap up because we are about at time. I want to thank all of our speakers for attending today, and I want to thank all of our listeners for attending as well. Oh, I do see a question coming in. Is there a customer city of okay, so this is for specific, like, larger districts. Is there a customer city of one of our specific districts that will be responsible for any fees? North Texas Municipal Water District, but that we can maybe expand that a little bit to ask, how do our water districts, are those things going to then flow down to our customer cities to then be responsible for our local governments and things of that nature? Does anyone know have any knowledge to speak to that?
I'd say everyone's grappling with how things are going to get paid for. As I said before, there's grants coming out. Somebody pays for those grants. There is some amount of money coming out of these lawsuits, but the producers are getting hit by every angle. On average, for like the last 6 years, there have been four individual, I think, lawsuits on average filed. I think there's close to 7,000 lawsuits related to PFAS filed nationally to date. That's an average of 4 a day. The federal judge recognized that the market cap for the major producers of PFAS is smaller than the potential long-term costs of dealing with the drinking water problem alone. So I think it's a massive, like, amount of money that needs to get spent nationally that the community is really grappling with. And I think over the next 5 years during the compliance period, and as I said, there's a lot of challenges, especially with the recent changes coming from the Supreme Court. That time frame may get pushed out a little bit more, but everyone's going to be dealing with it. I think, folks like a lot of us in the consultant class, including myself, will probably be busy with this, that have done a lot of funding strategies in the past. Everyone's going to be probably dealing with it in a slightly different fashion, but yeah, it is what like fees like water flows downhill.
Stay tuned for more.
I
Okay,
think
so
it's too early to tell. Yeah.
Yeah.
How it's going to work. Yeah.
now we'll go ahead and wrap up. I'm going to put a link into the chat that will allow you to provide feedback on today's webinar. It is a brief survey, but it is valuable feedback to improve our webinars going forward. So please give us your honest feedback. As a reminder, if you submitted an RSVP, if you registered, you will receive an email with presentation slides and a link to the recording when it is ready. All of our presentation slides will be on our Water Resources website, and I will put the link to that in the chat as well. If you did not register, but you would still like the materials, please email me. My email is in the chat. It's aknox@nctcog.org. Other than that, I want to thank you all for attending. I want to thank our speakers. Please feel free to reach out if you have any more questions or you think of other things that they can help you answer as we grapple with this topic. Other than that, have a great rest of your day. This webinar is over.
Thank you.
Thank you.
Goodbye. Thanks.